This is the beginning of making a batch of biodiesel.
All right.
I'm doing a test 1 liter batch to determine the proper proportions of lye to methanol that I need to use to make it. I'll be determining that by doing a titration test first.
Good. So, now by volume, how much oil do you have in that? That's a liter, did you say? Or
yes, there's 1 liter in here, and I'm heating it up and stirring it.
All right.
I've already taken 1 milliliter of this oil and put it in this container.
Okay.
With this eyedropper. It's graduated in milliliters.
All right.
Now I'm going to add the 10 milliliters of methanol required to do the titration.
Great. Now the titration, you have to determine that because what does that do, Dave?
It tells you how acidic the oil is.
Okay.
So that you can get the proper mixture of lye and methanol to do the chemical reaction to convert it from triglycerides to methyl esters.
I see. And then, as I understand it, it separates the glycerin away from the methyl esters, right?
Yes.
Okay.
It strips the glycerin molecule away from the 3 ester chains.
Okay.
And replaces it with a methanol molecule, hence the terminology methyl esters.
Okay, good.
And the glycerin is what settles to the bottom if we have a successful reaction.
I see. So the esters are there alone, and they're waiting for the methanol to join them, and then they become methyl esters.
Correct.
We got it.
I'm putting in a solution. This is turmeric, what you would maybe buy right off the shelf to do cooking with.
Okay.
Ground turmeric. That gives the sample some coloration to be able to turn it from this yellow color to a reddish color, pinkish reddish color when we get the solution correct.
I see.
Just checking now for temperature. I like to get it 3, that's warm enough. Now this is a titration solution which is made up of 1 gram of lye per liter of distilled water. I'm going to drop that in the measured amounts of tenths of milliliters. And that's how I'll ultimately determine how much I'm going to need.
Okay.
I'm going to start out with 3 milliliters.
I see. And each milliliter is a percentage then, correct?
Yes.
Okay.
I'm going to put 5 tenths in there and shake it up a little bit. There's been no change, so now I'll go to 1 full milliliter.
So you're looking for that color to change?
Yes. Yep. There goes 1.5. Still not there. 2. I noticed just a little bit there. 2.5. 2.3 or 2.8. There, we got that change, and you can see it now clearly.
Okay, yeah.
That was at 2.8 milliliters.
And once that color changes to that sort of a pinkish roses color, then you know that that's your percentage of titration.
Now I'm going to record it, 2.8. I have determined I'm going to use 7.8 grams of lye to 200. So that will do a 1 liter batch, which I'm cooling off right now. So I'll go to my scale.
So this is all based on that mathematical equation of the percentage by which you titrated, and then you've figured that how much lye you're supposed to add.
Right. This is going to determine per liter how much lye, and then I'll ultimately convert that to gallons, to the amount of gallons of vegetable I'm going to mix to react. So we've got 7.8 grams of lye. I'm going to add 200 milliliters of methanol. Which the 200 milliliters of methanol represents 20% by volume of the 1,000 milliliters of oil.
Got it.
I'm going to react.
So that is irrespective. It has
Yes.
nothing to do with the percentage. That's just by volume.
The amount of lye is the only thing that changes.
I see. Okay.
Now we're going to mix this up. I hope this cools down a little bit. I got it a little too hot. This mixture is now called sodium methoxide.
Okay. Now, is that at all hazardous in any way, Dave?
Extremely. That's why
Really?
I'm taking precautions here with the towel.
Okay.
Got a cork in it.
So our friends who are watching this ought to be very careful in handling the
Absolutely.
methoxide.
It's extremely caustic.
Okay.
Could burn the skin. And you just continue to shake it until all the particulates are dissolved and you have a good even solution.
I see.